Hi everyone, welcome back to lecture 3 in a course microcontroller. So in the last two lecture we discussed about overview of 8051 microcontroller and architecture of 8051 with some internal components of 8051. So this lecture we are going to discuss the remaining components, internal components of 8051 and the pin configuration of 8051. So pin configuration of 8051. So 8051 is the 8-bit microcontroller which has a 40 pin uh, dual in package integrated circuit. And so which are the components we already discussed in architecture will view, that is inputs and output pins we can see in 8051 pin configuration. So 8051 the biasing can be done with the pin 40 and 20. So pin 40 will give VCC, positive VCC, and pin 20 is dedicated for the ground or VSS. And remaining pins we are splitting the pins with respect to the parallel IO ports. So four IO ports are there in 8051, that is P0, P1, P2 and P3. So P0 to P0.0 to P0.7 is the 8 port pins, that is pin number 32 to 39. So these ports is dedicated to transfer the address and data, 8 bit of address and data, because address bus and data bus is multiplexed here. So therefore the lower order address bus and the data bus of D0 to D7 are get multiplexed and it is communicated through P0.0 to P0.7. At the same time, the port number 2 P2.0 to P2.7 is dedicated for communication of the address line, that is higher order address lines, address 8 to address line 15. So it is used in the pin number 21 to 28. So remaining 31, 30 and 29, that is program status enable pin, it is used in 29, pin number 29, and pin number 30 is address latch enable, that is, so during multiplexing we need to latch some address lines that can be performed by using pin number 30, address latch enable. And 31, so during interfacing of microcontroller with the external memory, EA pin is used, external access pin, so either it will be connected to ground or plus VCC in order to fetch the external memory to the microcontroller. And the pin number 19 and 18, so these are used for an oscillator input to an 8051. And the pin port numbers, port 3, that is P3.0 to P3.7 has a different functions, that is P3.0 and P3.1 is used for serial communication, that is RxD and TxD. RxD is for receiving the information to 8051 and TxD pin is used to transfer the serial information from 8051 to external peripheral device. And P3.2, P3.3 is an interrupt source. The two interrupts are there, that is int 0 and int 1. So this can be accessed through the pin 12 and 13. And P3.4, 3.5 is used for the timers, that is 14 is for timer 0 and 15 pin is used for timer 1. And P3.6, P3.7 is for read and write the information through a microcontroller. 16 is to write the information and 17 pin is used to read the information. So this is about the pin configuration of 8051. So so this is about the pin configuration. So in the next concept is the memory organization of 8051. So memory organization. So memory is a semiconductor storage cell used to store the binary information. We already know that two types of memories we are used in processor, that is program memory and data memory. So program memory is nothing but a ROM and data memory is nothing but a RAM. 8051 has an internal RAM because inbuilt uh, RAM is accessed, that is 128 bytes of RAM and 4 kilobytes of ROM to program the microcontroller. So RAM is used to store the data and ROM is used to program the 8051. So first we'll discuss the internal RAM structure of 8051. So internal RAM structure, we know that 8051 has a 128 bytes of RAM to store the data. So that 128 bytes, lower 128 byte is consumed for the general purpose RAM, or we may call it as a working registers, and higher, that are upper 128 byte, is dedicated for the special function register and also stack registers. That is 002 to 7F is used for general purpose RAM or working registers, and 80 to 802 FF locations can be fetched for the special function register application or stack application. Here we can define the memory locations of the RAM, that is lower 128 bytes can be utilized by both indirect and direct addressing mode, but the upper 128 byte the stack can be accessed by using indirect addressing mode, and the 128 byte can be directly accessed by to fetch the special function registers. So we already discussed the four different register banks are there. So the lower 128 byte, that is internal general purpose RAM, that is it is 002 FF locations. 002 1F locations can be divided into four different register banks, that is register bank 0, register bank 1, register bank 2, register bank 3. So each register bank has capability to store the 8-bit of information. So that is, it has 8 different register or not, which has, there is register bank 0 has R0 to R7 registers. So each register which can able to store 1 bit of information. So total one bank consists 8 bit of 8 register. 8 register will stores the 8 bit of information. So it is same for bank 1 and same for bank 2 and bank 3. And so remaining 2022F locations can be used to store the bit addressable. Some bit addressable information data will be stored in this 2022F, and 2822F we can fetch the scratchpad memory or the general purpose application, we can store some information. And special function registers, that is stack operation or special function register, which can be accessed by direct addressing mode. We need to directly specify the location. We can fetch nearly common 21 the locations from 80 to FF. We are using frequently we are using common 21 registers. So those special function register I mentioned here. So the application of special function register is to monitor and control the operation of logical and arithmetic operation in 8051. So special function registers are accumulator and B register, port 0, stack pointer, DPL, DPH or pointer register. So TCON and TMOD are timer registers. TL0, TL1, TH0, TH1 is also a timers. So we can access the locations of the timers, that is TL0 uses the location 8A, TL1 uses the location 8B, TH0 at 8C, TH1 at 8D. Okay, so these RAM memory locations is dedicated for the special function register applications. So on port 1 IO, ports 1, port 2, port 3 uses the locations 90 A0, B0, 98 B0, and the serial communication, so S buffer 98 location, SCON 99, PCON 87, PSW, PSW, the program status word has the D0 location, and IE register has the location of A8, and IP has B8 locations. So this is about internal RAM structure. But in few applications we requires more memory locations, that is RAM, because 128 byte is not enough to store some to perform some specific application. During that time you can able to extend the capacity of the RAM by interfacing an external RAM chips to the 8051. So let us see how to interface the RAM chips to the microcontroller. So here is an external RAM which is connected to an 8051 microcontroller. External RAM 8051 has 128 byte and 120, that is 8051 has only 128 byte internal memory, but it can be extendable up to a 64 kilobyte by interfacing external RAM chip to 8051. So this is a block diagram to connect external RAM chip to 8051. So this is an external chip, RAM chip. It is connected to 8051 microcontroller. So we know that the port P0 and P2 is used to access the 16-bit address, and P0 is multiplexed with lower order address bytes of A0 to A7, and also the data lines D0 to D7. Okay, so port P0 is connected with the connected to RAM chip, and it can be access both the address and data, D0 to D7 data and A0 to A7 address lines. So here is the latch circuit. So through this latch, by one control pin, that is address latch enable pin. So address latch enable pin is used to latch the address, that is lower order address, during the communication of the data from microcontroller to RAM, or RAM to 8051. So in order to enable the communication or fetching the RAM locations by 8051, we need to use one control pin, that is EA. EA is nothing but external access. So this is active low pin, that means it will get activated by giving zero potential to this pin. Therefore if you are connecting EA pin to the 0, so you can able to access the RAM. Otherwise it will doesn't allow 8051 microcontroller to access the RAM. So in order to fetch the information from the RAM, you need to enable EA pin. At the same time, the P2 pin is used to access the higher order address from A8 to A15, and read and write are the control signals of the RAM. At the same time, RAM has the RAM also has the write control and the output enable pin. So read can be possible by enabling the RAM outputs. Okay, therefore OA pin that is read pin of 8051 is directly connected to the OA pin. So during accessing the RAM, so first we need to enable the address pins, that is which information in the RAM we need to fetch, or which location we need to fetch. That can be enabled by enabling the lower order and higher order address and putting particular data of through a data line from 8051 and read the information. If you want the read operation, you enable the read pin in 8051. You can able to read the information. If you want to write the information, we need to write the information on the RAM chip. So this is a fetching procedure of external RAM. And internal RAM, so until we discuss about the RAM, now we move towards the internal ROM structure of 8051. As we know that from the future, the 8051 has the 4 KB of ROM. So 4 KB of ROM, that is we can able to access the 0000H to 0FFFH locations in 8051 ROM. So ROM is a non-volatile memory. That means once we write the information in this memory location, we can store for the long period. Even if the power will get failure, the data will not get erased. Therefore we are using it as a program memory. So this also we can able to extend the ROM locations up to 64 kilobytes, because it has only 4 kilobyte. In some specific applications it requires 64 KB also. So as like interfacing of RAM, so ROM chip was also interface to 8051 as like RAM. Here also the same procedure. EA pin is connected, so it will make it as a 0 to fetch the information from the ROM, or we can able to program the ROM, because ROM we need to write only, no read option. So therefore only one control pin is there, that is PSEN. So through this PSEN pin we can enable the ROM chip, and we need to put an address, lower order address in through the port P0 A0 to A7. So during that time the data we will not transfer any data. So once we put an address, after that we need to transfer the data, and also we need to put the higher order address through the port 2. Okay, so this is an interfacing of ROM chip to 8051. So next important concept, that is counters and timers. So counters and timers, so timer is also a digital device used to generate the time delay. So by using the timers we can able to generate the time delay in 8051 microcontroller. And the counter is also a digital device used to count the event. We know that the 8051 microcontroller will connected with the oscillators, crystal oscillator, which will generate the clock signals to 8051 through the XTEL2 and XTEL1 pins are there. Through that we can get the clock signal. Clock signals is nothing but a clock pulse which has the logical 1 and logical 0, that is positive and 0 status. So it will varies from one it has a unit positive and negative pulses.